Okay, it says assume that the paired data come from a population that is normally distributed using a 0.05 level of significance and d equals x minus y. Find d bar, that means the average of the differences, and SD, the standard deviation of those differences, the t-test statistic, and the critical values to test the claim that UD equals 0. All right, we're going to use StatCrunch to do all of this, so open in StatCrunch. Okay, let's first go ahead and do a paired t-test. So go to Stat, T-Stat, Paired. We're going to do x minus y. Notice we have mu1 minus mu2, kind of goes in that same order, x and then y. Hypothesis test. Let's go ahead and save the differences. We'll need those in a minute. That's important. Make sure you do that. And press compute. Notice it put my differences in another column right there. Okay, so the mean of x minus y is 2.125. So I put 2.125. Now the standard deviation of those differences. Be nice if StatCrunch gave you that in the same window here. They don't. That's standard error, which is not the same thing. So what I need to do, let me close out of this. Or minimize it. There we go. I need to find the standard deviation of this column. So I'm just going to go to my stat and run a summary stat on that column. Just need it on the differences. Make sure standard deviation is selected. It is right there. Press compute. So standard deviation 3.227 for this particular one, 3.227. Now it wants to know the t-test statistic. We already have that. So it is right here. 1.863. 1.863. And finally, the critical values. Now we're not going to be doing these by hand. This problem sort of is geared to that. So I want to show you how you can do this again using StatCrunch. I'm going to do it using an applet. So I'm going to go to Stat, Calculators, and it is a T calculator is what I need. Okay, so we're going to do the between, and our degrees of freedom, remember, is n minus 1. So what do I have here? I've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 1, 7. So I want to put my DF at 7. And then I want that 0.95, right? Because we have a 0.05 level of significance. So 0.95, compute. And this is what it is. It's 2.365. So plus or minus 2.365. So I hope that helps.